If this relief valve has the correct nameplate and the correct set pressure, are we safe? Not necessarily. The valve is only one component of an overpressure protection system. A pressure relief device exists to stop protected equipment exceeding its allowable pressure limits under credible contingencies. HSE guidance requires protective devices to function properly and stay correctly adjusted. API 520 Part 1 covers sizing and selection, Part 2 covers installation, and API 521 covers relief and depressuring system design. Exact requirements depend on the controlling edition, equipment code, and jurisdiction. Starting with valve area instead of credible overpressure scenarios. The required load comes from the scenario: blocked outlet, control failure, fire, thermal expansion, tube rupture, or gas blowback. Confusing set pressure, accumulation, overpressure, and MAWP. Use the definitions and limits in the controlling code. Using wrong or stale process data. Relieving temperature, molecular weight, density, phase behavior, upstream source pressure, or heat input. Ignoring two-phase or flashing behavior. A single-phase equation applied to the wrong regime misrepresents capacity. Treating inlet piping as harmless. Excessive non-recoverable inlet load destabilizes a spring-loaded valve and contributes to chatter. Ignoring outlet back pressure and disposal system interaction. Build-up or superimposed back pressure affects capacity and stability, and simultaneous relief loads can overload a common flare header. Installing isolation that can separate the relief device from the protected equipment during operation, or routing discharge to an unsafe location. Failing to maintain the design basis. Changes in feed, control valves, operating pressure, heat input, piping, flare headers, or equipment service can invalidate an old relief study. Take a separator protected by a spring-loaded PSV. A revamp raises upstream pressure and installs a control valve with a larger CD, but the PSV nameplate is unchanged. Verify the new required relief rate, actual relieving properties, inlet loads, back pressure, flare header simultaneous loads, certified capacity, isolation position, and inspection history. Same PSV does not mean same protection. 10-point review. Scenario register, current process data, correct fluid and phase model, set pressure check, certified capacity, inlet losses, back pressure, safe disposal, inspection records, and management of change. The most dangerous relief valve mistake is believing the valve alone is the protection system. Follow PEQ Academy for practical pressure equipment engineering.